Good morning, everyone. Welcome to the presentation. I am Jayani Withanawasam, a senior software engineer from Zaizi R&D team. I have worked with several natural language processing, machine learning, and semantic projects. And in Zaizi R&D team, we are very excited about coming up with applying these technologies in content management systems domain to make intelligent content management systems. So in this presentation, we will see how we can effectively apply machine learning techniques into content management systems such as Alfresco. So idea is to organize the Alfresco content better using these machine learning techniques. So before going into the presentation, let me introduce my sponsor, the Zaizi. So we are leading in smart content solutions, and I am very proud about this, our history. We are Platinum Partner and Best System Integrator Partner of year 2012 and 2013. So here's the agenda for the event. So at the end of this presentation, I want you all to take home three things. Just three things, so no big deal. So the first one is the problem in business content. Basically, why we need this solution? What is the problem we are trying to solve by this solution? And the second one is what is our solution? What are the features we are giving? And there I will give you a brief introduction about artificial intelligence and machine learning as well. And then we will go to the real implementation with the demo on how we have implemented this machine learning Alfresco integration. So why? The problem in business context. So I've got a video for you to show you the actual problem that we are trying to solve. So that's me. And going back to the presentation, so as you can see, having a lot of content doesn't make any sense if you can't find the right information at the right time you want and whenever you want. So we will now discuss about the problem a bit. So I think we introduced Mike to you, the senior government officer. So now he has this problem of not having the information organized properly, and now he's thinking like what can be the reason. So he's thinking, okay, they're using their current ECM is Alfresco, and Alfresco is providing great features to organize the metadata and organize the content such as categories, tags and content model properties, and also to come up with a taxonomy structure, and using category manager And these features will, in Alfresco, these features will enable you to properly structure the unstructured content you have, and also this will help to get some meaning from the content, and also this content will enable the findability as well. So then what's the problem? So when he is thinking about the problem, he realized that there are like more than 100 employees working under him, and everyone is contributing to this metadata. Everyone is participating in metadata creation. So there he sees a problem in this manual metadata creation. Basically, when humans are entering metadata, sometimes there cannot be any metadata available to the even though when you upload a document, sometimes people are lazy, so they won't add valuable metadata to the content. And sometimes even if you add metadata, the metadata will not be consistent. For example, there can be like different users might enter their understanding about the domain will be different. So, and also there might be like synonyms and abbreviations, and these things will cause semantic ambiguity. So he's thinking, okay, what if I hire a taxonomist to organize this content? But then again, the problem is he will charge you a lot of money, and it will take a lot of time for him to properly tag and label the content and come up with a proper structure. And also this task will be like time consuming and labor intensive. And then he is thinking about a rule based approach. What if I come up with some rules and execute them to organize this content? But then again, the problem is the rule based approach is not learning, not learning and improving, and it needs human involvement. And also it is not adapting fast to the changing business needs. So it is not like, in long term, it is not a sustainable solution. And also I think in Alfresco there are some metadata that is automatically added to the content, like for example author and size of the document and maybe the created date. But the problem with this metadata is these metadata will not actually represent the content, the actual content. Like for example, it is not properly representing the structure, meaning or the context of the content. So okay, because of these problems, there can be stakeholder dissatisfaction, and obviously additional cost and loss of productivity because lot of manual work, and at the end of the day it will be loss of profit. And basically profit is something very a key goal in driving a business. So I think you understand how critical this problem is and why we need to solve this. So before explaining how we solve this problem using artificial intelligence and machine learning, I will explain you what these concepts are first, and then we will go into our solution. So artificial intelligence. So how many of you are excited about artificial intelligence? And how many of you are scared about artificial intelligence? Okay, 2 people. So basically artificial intelligence is giving the ability, enabling machines to do the task that requires the human intelligence. Those tasks can be the tasks such as problem solving, thinking, and knowledge, reasoning, and navigation. So in artificial intelligence, there are different areas to address each of these, to give these capabilities to machine. So for example, this navigation, robotics is the area we are addressing this navigation, and image and video processing will be addressing the perception, and Semantics will be addressing knowledge representation. So machine learning is the area where we are trying to give machines the capability to learn. So in machine learning, so Andrew Ng, who is the director of the Stanford Artificial Intelligence Lab, has mentioned that machine learning is the most exciting area in the computer science field. And also it is an area where it is a branch in artificial intelligence which is highly applied in the practical scenarios, such as there are like many different applications like computer vision and medical diagnosis, and also financial analytics and bioinformatics. There are like many different areas where we can apply this. So also I think in our day-to-day life, without maybe knowing, we are using the machine learning. So how many of you know that your email provider is using machine learning for spam detection? Okay, there is one person. And also there are another application in machine learning where they are recording the audio in C, audio recordings in the sea, and they are using them to identify the whales and how to prevent whales from colliding with the ships. So like the applications are like, there are many different applications. So today we will be focusing on the application of machine learning in ECM domain, basically content management systems. So to explain machine learning, I will so we will see how we can implement machine learning. So in the first step in machine learning is, so for this one we will get content management system scenario. So we will see how we can auto classify documents using machine learning. Basically how you can assign a document automatically to a document using machine learning. So the first step is training data. We have to come up with training data. So what is training data? I think you can remember I told you that machine learning is the we are achieving machine. To learn, how we are learning is using past experience and knowledge. So training data is what we are getting this past experience and knowledge. And so we take this government use case because it was government is where this mic worked, and we can take government historical data as training data. And also during the training phase we need to analyze the features. So features in machine learning is, the meaning is different. So feature means some of the characteristics where you can distinguish a particular category, a particular document in a particular category from another document in a different category. So in text domain we will be using terms, mostly the terms which provides us a great strength to distinguish between the categories. So for example, if you take a term like the, or some common terms, they are not like this, they are not very helpful for us to distinguish between categories. But if you take, so in this scenario, press release, if press release is the category, news, the term news will be very helpful to identify, okay, that this document belongs to news category. And so also we are using a concept called TF-IDF, term frequency and inverse document frequency, to identify the most important word to in a document in the collection of these documents. So these are the things we are considering as features during the training process. So after the training process, we will apply the machine learning algorithm to this training data, and we will come up with a machine learning model. So machine learning model is like the brain of this system. It is it is what that is capable of making smart predictions on data. So once we come up with the model, once we provide a new document to the model, it will infer the category. So in this case, we will give a document on rules and regulations to manage international parties, and the model will decide, okay, the category is policy paper. So in machine learning, there are two different methods of handling this process. So first one is supervised learning, and the other one is unsupervised learning. Both mainly like both are like giving similar results, but the difference is for supervised learning you need to provide some label data, whereas unsupervised learning you don't need to provide any labeled data. And in supervised learning, what we are doing is we are trying to model a relationship between the features we extracted and the label. But in unsupervised learning, we are trying to come up with some hidden structure in the document, in the document repository, and this is basically we are achieving through a similarity measure, like we are measuring the distance between similarity distance between the documents using those TF-IDF which I mentioned earlier. So these are some of the algorithms we have used to enable machine learning, and these are some of the Mahout, Mallet and OpenNLP are some of the libraries we used for this. And okay, why machine learning? Because it eliminates the need of human expertise. Basically, machine learning, it will enable, it will help you to automate this metadata generation process. So it will eliminate this human involvement and intelligent decision making. And self-learning and adaptation. Basically, this machine learning model we can like regenerate without having any human involvement. So it's kind of self-learning and adapting with the, like if your business environment is changing, it is automatically adapting to that business environment without any human involvement. And also smart prediction and inferring. Basically, in machine learning, you can apply machine learning to areas where you can't program everything explicitly. Areas where you can't program everything in advance. So it is capable of learning without program explicitly. And automated pattern recognition. As I mentioned, in clustering, it is possible to recognize the patterns in your repository without any human involvement. So these are the features we have provided. Automated contextual metadata means we are providing some metadata that represents the context, and contextual recommendations, we are recommending similar documents based on the context. So, and also we have some search enhancements, for especially when filtering the search when you have too many documents in your repository in the search result. And there we have two features, contextual faceted search and advanced search customizations. So basically the idea is to first organize your repository and then enable it to find the content easily, find relevant content easily, and then provide the facilities to analyze the content and to gain some insight from the data. So these things actually I will be explaining properly in the demo, and this is the high level design of the system. First, the admin has to train the system. This is to learn from the previous experience and the knowledge. And then the machine learning component will come up with the model which is capable of making smart decisions. And then when the end user is uploading the document, we are sending it to machine learning component to make decisions about, say, for example, what is the category of the document. something like that, and then it will send us back the contextual metadata that can be added to the document. So then with the document we are saving this metadata in the document repository. So once this metadata is attached to the document, we can gain some other features such as contextual recommendations, advanced search result, and advanced contextual search. So this is the most important feature in this application, machine learning with Alfresco, because this is the key area where we are adding the metadata to the document. So analyze content and provide representational metadata. What I mean by representational is, it is representing the actual content of the document. And how we implemented this is using Alfresco custom content model and Alfresco custom behavior. So this is the design of that feature, where we trigger the machine learning component in node service on add aspect event, and then we analyze the content and then provide contextual data metadata back to the Alfresco, and then we set the properties and categories in Alfresco using these services. So contextual recommendations is, we are recommending contextually similar documents using these metadata added, metadata such as labels, topics, clusters, which we retrieved from machine learning the previous step. And then using Alfresco full text search, we are searching for similar documents and providing to end user. So for this we have done a share document library customization with custom minimal document details panel. This also you will see in the demo. And this is the design for the recommendations. And advanced search filtering. So basically we have invented contextual faceted search, where you can filter out your search results based on the context, actual context. And for this we have used Zaizi faceted search module, but I think in Alfresco 5 you can you have this faceted search, so it will be easier to use that search. And Alfresco advanced search customizations. There also we have added enabled to search by the topic and the label of the document. So we'll go to the demo one. So this is the government Alfresco website, and we'll see how we'll try to upload a document to the repository. So here's the document we have uploaded. And I think you can see the category is automatically assigned to the document, and also this category is referring to this taxonomy structure in the category manager. And we'll go to the content and we'll see some additional metadata that is assigned to the document. So I think in document properties you can see the clusters and topic as education, and cluster is finance, and the label is Rwanda. So this is something about the document basically, not like the other metadata where you say created date or author. And also we have this document recommendations feature, where it is suggesting you the documents, similar documents it thinks that is related to this one. So this is something similar to YouTube. I think you have seen YouTube recommendations. And now we will see the search functionalities, search features, new search features. So this is advanced search, and there we have introduced new custom search called contextual search, where you can search from the context. So I think you can see previously we uploaded a document related to Rwanda education. So say now this Mike wants to find what are the other projects we have done in with Rwanda. So you can search with this label Rwanda, and it will give the results, it will filter out the results based on that. And also with faceted search we can further filter out these results with topics. So basically we are saying, okay, in Rwanda we have done both education and climate change project. Which one you are interested? So if you say education, then only the education results will be shown. So in this way, if you have a huge document collection, you can filter out only what you want, only what is relevant to your need very quickly. So these are the end user features. So we'll go back to the presentation. So also these are the potential machine learning application areas in Alfresco. I think all of you are familiar with Alfresco records management and Alfresco category manager. So in Alfresco records management, we need to decide the type of the documents. To apply different rules to these folders, we need to first identify the type of the documents. So for that, we can use machine learning to automate finding type of the document. And also in Alfresco taxonomy creation is another area which we are looking into. Using unsupervised learning, we can automatically find the hidden structures in your repository and create a taxonomy automatically in Alfresco. So you don't have to like manually do this. So the next thing is the training your repository. I think you can remember in the beginning I told, for machine learning we have to learn from the past experience and knowledge. So that is training the repository. So for that we have two different methods. I think I will explain this during the demo. So we'll go to demo 2. So this is basically admin functionality. Admin has to do this once when you are applying machine learning capabilities to the system. Also this training part we can schedule using a cron job as well. So for this we have done a customization in Alfresco admin console. And I think you can see the 3 different machine learning techniques: clustering, classification and topic modeling. So first we'll looking into classification. So in classification we need to have a hierarchy, folder hierarchy in the local file system. This is one requirement from machine learning side. So you need to have a proper folder hierarchy, and folder name should be the category name in the local file system. You need to have something like this. But the problem is this type of hierarchy is not always practical in a business environment. You might have different structures. So because of that we have invented some pre-processing techniques. First we will train the repository. So once you train the repository, the machine learning model will be generated. And we will see the pre-processing techniques. So as I told you, that coming up with hierarchical folder structure is not a feasible thing. So we are giving few other options to enable this. So we can say, okay, if you have this hierarchy in Alfresco, then you can go with this. You can define the root folder and see, okay, use this repository for training. And also we are having two metadata based approaches. If you have the tags assigned to documents and categories already assigned to documents, then we can use that and do some internal processing and do this training process. And also, say you don't have anything, you don't have tags, your repository doesn't have consistent tags or categories, then we can apply a rule-based approach. So basically this is showing the categories where you have already, and next one will be the rule-based approach. So in rule-based approach, you can, this is basically done using the regular expressions. You can come up with the rules.xml, something, a file like this, and you can say, okay, if the document contains Bangladesh, India or Sri Lanka, these methods, these terms, then assign the category as Asia. So this is some initial step to enable the training process. This is like very simple regular expression. You can give anything you like. And okay, now we'll see, you don't have that, you don't have any, you don't want to do anything manually, then you can go for this unsupervised learning methods and call clustering and topic annotation to enable training process. So see, these documents doesn't have any metadata, but still we can categorize these documents. So basically, topic modeling is also a unsupervised learning method. So I think I don't have much time left. We'll go to the slides back. So this is a comparison between supervised learning and unsupervised learning. Basically, the difference is label data is required, but for supervised learning, there are methods like semi-supervised learning and active learning methods to solve this requirement of this label data issue. And also this, even though I say this is more accurate, it depends on your training data available and the machine learning algorithm you use as well. But it is more accurate because of the human involvement. This is like you have to compromise either accuracy or versus performance. So these are the advantages of the system. So now Mike has used these features and now he is happy because it is automatically recognizing patterns and also give relevant search results and provide automatic tagging, contextual recommendations, and at the end of the day it is improving the user experience. So these are the business benefits that you will gain from the above advantages. Basically, it will improve the productivity because it will eliminate the human involvement, and also knowledge management is improved because your content is structured, and also time and the cost will be saved as well. Also, you can gain competitive advantage because these days the content and the structure is changing very frequently. So if you can adapt to this content and organize your repository very fast, then you can shine, you can gain this competitive advantage over the others. So these are the challenges we face during this implementation. As I mentioned, first we have this accuracy or performance issue, and also file transferring will be there to between different servers, so network bandwidth issue is there, and also with same as goes with the replication, and also there might be security concerns with sensitive documents which we use for training, and scalability because machine learning algorithms are very computationally intensive. So we need to scale this computation of the algorithms to gain better performance. And change management, like okay, whenever you say we are going to automate this, some people might say okay, I will be having will my job like job security issues, and some people are not ready to accept the different things. So okay, now this is a very important slide because just by applying machine learning techniques, you can't gain a successful outcome if you didn't consider these aspects. Like basically model accuracy is very important to get good outcome from machine learning techniques, and customer satisfaction mainly depends on this. And to make this model accurate, we have to come up with a rich training data set and consciously selected features. Training data set is very important because if you are having very few documents to train, then I think you shouldn't go with machine learning. You better use other manual processes. But if your data set is huge and you can't manage it, machine learning will be the good option. So also when we are selecting the features, also you can consider like different terms and combination between terms and different metadata, and also the formatting of the content. So these are the future, this is our to-do list for Zaizi R&D team. So content analysis, we are trying to analyze the trends in your document collection, because basically this is one capability from using topic modeling. And also user behavior analysis, like if you analyze the user behavior and also contextually aware content, if you know the content and the user, you can give some personalized results to the user. And also we are looking into pre-trained models because model creation is a very expensive process, and incremental learning is to improve the performance. There we are considering only the change documents to generate the model, not the entire content all the time. So any suggestions with this? So if you have any suggestions even after the session, just let me know. And so these are the people who are behind the scenes, like, so I will take this opportunity to thank them. And you can find some more information about this machine learning solution in these links. And also if you have, if you want to know more about this, then let us know. And any questions? Okay.
So the supervised learning is more accurate, we find the same, but it has errors as well.
Okay.
And I guess the answer is, to the question I'm going to ask is, it depends on the data set. But what do you find is a typical worthy sized training set? So if you have a classification of, say, just keep it simple, 5 categories, you'll have 1,000 documents in each category to train in.
Okay.
We often find 1,000 isn't enough. I mean, what's your experience?
So like
The training set?
the size in the sense, so it depends on the nature of your content as well. Because like I can't give like exact figure.
But in your experience, what do you usually find is a good set?
So if you can, okay, if you say 2 categories, then maybe 100 documents. Yeah, but it like I said, it totally depending on the machine learning algorithm we use, plus the nature of the content. Like how can we distinguish between categories? How easy it is to distinguish between categories?
Thank you. So where I'm leading is it's difficult to measure the accuracy of the supervised learning, which is over
Yeah.
So it would be easy if rather than sort of proactively just every 6 months doing it just in case, having a decent algorithm for knowing when it's inaccurate. What kind of process do you recommend for measuring the accuracy of the learning process?
So there is something called cross-validation in machine learning. There you can come up with different models and try it with your training data set, and you will have a test set, and there you can see which model is accurate for your solution basically.
Yeah.
And also you can try out with different algorithms as well.
Yeah. No, I was thinking more that once you've done that, you've chosen the right algorithm, it still deteriorates over time because of the changing context.
Yeah, because like whenever we generate a model, it's different.
Yeah, so it'd be nice if we could measure, it's dropped below after a year, it's dropped below a critical threshold. I'll take this offline.
Sorry, I didn't.
It's fine.
Okay.
Thank you very much. That's good answer.
And your question?
Regarding asked about the data set, but any other than that, then how huge is the implementation effort for this model?
Implementation effort.
How many people work on
So in Zaizi R&D team, we work like 5 people, and for 7 months, I think. That is like machine learning integration plus Alfresco development, both. Okay, any other questions?
What about the corrections to what the machine learning algorithm figures out? So it figures out like 2 categories, but then a human can intervene like, okay, this is just wrong. Does it learn from that further, or?
Yeah, in machine learning there are ways to enable this, but in our solution we haven't done it yet. So there's something called relevance feedback. So there you get, if a user says like, okay, this is relevant to my search query, then it will consider that action to retrain the module. I mean, to improve the module.
And another, you started by saying that terms like A and for and stuff, they're not really relevant and so on. Do you consider using an algorithm also for feature reduction, like figuring out which terms to ignore in the future to improve accuracy?
Yeah, that's true. Because like in our case, we use this stop word analysis. So these are called like stop words, where the and or these type of things first we will eliminate, because
Yeah, you eliminate those, but maybe there are terms like, I know you mentioned news. So
Yeah.
I also use that example, but maybe news is just too widely used in different categories, and considering it just ruins your accuracy. So you need to.
Yeah, and sometimes there will be like verbs also. I have seen like when we are developing, there are like different verbs we couldn't eliminate, but if we eliminate, we will get a better results. So for this example, I just use and the, but actually we are removing this during stop word remove.
So I guess it also, it also depends on the data.
Yeah.
Which algorithm you put.
So you can use like that type of pre-processing activities to refine your training data set before you send it to model creation. Yeah.
So have you implemented the system in the real world yet, or is it still a proof of concept and product development?
So currently we have a demo version, and we are looking into come up with a product as well. So any other questions? Okay. No questions? Thank you.